Hello friends, we're going to look at the sum of an arithmetic series in this video. Sum of a geometric series is in the next video. Here we've got it, and we're going to go back to our friend Carl Friedrich Gauss, he of the fundamental theorem of algebra, and a story that takes place when he is in second grade, according to his biography. And so what we have is a second grade teacher who is frustrated at an annoying very smart person and gives him a task. Add up the numbers 1 to 100, expecting that this will take him about 15 minutes, during which time the teacher can pay attention to the other children in the class. However, Gauss, being very clever, does not take 15 minutes, even as a second grader. 1 plus 101, 1 plus 100 adds up to 101, he notices. And likewise, 2 plus 99 is 101, and so is 3 plus 98. And in fact, every pair is going to be adding up to 101. Every pair of numbers here in this series, if you take the first and the last. And there are 50 pairs because there are 100 numbers in the series. 50 times 101, 50 times 100 is 5,000, 50 times 1 is 50, 5,050, and in less than 50 seconds, the second grader comes up with this answer, much to the consternation of his teacher. So, we're going to use that insight in order to find the general term for the sum of an arithmetic series. And in just a little vocabulary, a sequence is a list of numbers, and the series is the sum of that sequence. And so a general formula for the sum of an arithmetic series, like we just did, half the number of terms multiplied by the sum of the first term and the last term. So you take the first and last, add them together, and you're going to have this many pairs of those terms. Great. Let's do it with an example. So this is off of the skills pages, so you can use the skills pages while we're there, and we'll take care of it. We have an arithmetic sequence. You can recognize this sequence. It starts with 12 and has a common difference of 3. Find the fifth term and the 100th term, the sum of the first 5 terms and the first 100 terms. So we'll do the sum of the fifth term. In this case, we do need to find the fifth term first. A5 is 12 plus 3 times 5 minus 1, so it's 12 plus 3 times 4, which is another 12, that's 24. And so my sum of 5 terms is 5 over 2 times the first term, which is 12, plus the last term, which is 24. So 5 over 2 times 36 is 90. And we're good to go. The sum of the first 5 terms is 90. The sum of the first 100 terms is going to be a little bit larger because we're talking about big numbers here. The sum of the first 100 terms, A100, is 12 plus 3 times 99 for a total of 309. So the sum of 100 terms is going to be 100 over 2, 50 pairs. First term is 12, last term is 309. 50 times 12 plus 309 I have here, and it is 16,050. That's a calculator question. Good to go? How about another example? Here we're given a recursive version of the sequence. Well, this recursive formula is just as straightforward. We have the first term being 17. We have each term being the previous term minus 5. So we can actually set up an explicit formula for this if it would help us, and it probably will. A sub n is 17 minus 5 times n minus 1. So that'll help us find the first 5 terms, the sum of the first 5 terms. Although in this case, again, what's the fifth term? In this case, it's probably easiest because you have the recursive formula to just work it down. So 17 is the first term, minus 5 is 12, minus 5 is 7, minus 5 is 2, and minus 5 is negative 3. So the fifth term is negative 3, and the sum of the first 5 terms is therefore 5 over 2, how many terms you've got, times the first term plus the last term. So that's 5 over 2 times 14, same as 5 times 7, it's 35. The sum of the first 5 terms will be 35. Likewise, the sum of the first 100 terms. Why don't you pause, figure out if you can figure out the sum of the first 100 terms. And we'll come back when you've got it. All right, welcome back. The 100th term of this sequence is 17 minus 5 times 99. It's a big negative number. The 100th term of this sequence is negative 478. That's what I get. Negative 478, so that means the sum of the first 100 terms is 50, that's 100 over 2, times the first term, 17, plus the last term, minus 478. You notice this sequence is decreasing. A lot of the terms are negative. Therefore, we're going to get a big negative answer here. So, work that out, and you get negative 23,050. Exactly what we were thinking. Negative 23,050. There we go. Hope you got that when you're working on your own. Two more quick ones here. Actually, the first one is very quick because it's the same one that we did with Gauss. We had the first term plus the last term. We had 100 terms. The first term 1, the last term 100, for a total of 50-50. But this last one is a little bit of a challenge because you don't know how many terms. So you do know the first term is 12. You do know the last term is negative 18. So we know that it's decreasing. We know that it's decreasing by 1.5 each time, minus 1.5 each time, minus 1.5, minus 1.5. But we don't know how many terms there are. So that's the first thing we have to figure out. Which term is that negative 18? Negative 18. My formula for this sequence will be 12 minus 1.5 times n minus 1. That's your explicit formula for a sequence that starts with 12 and decreases by 1.5 each time. An arithmetic sequence that does that. So, we've got negative 18 equals negative 12 if I distribute minus 1.5n plus 1.5. Add 12 to both sides, subtract 1.5 from both sides. I got negative 7. No, this is positive 12. So, subtract 12 from both sides. I've got 30. Subtract another 1.5. I've got negative 31.5 equals negative 1.5n. So, n is 21. I have 21 terms in this sequence. I already knew the first term. I already knew the last term. That gives me everything I need to know. 21, the sum of 21 terms is 21 over 2 times the first term, which is 12, and the last term, which is negative 18. So 21 over 2 times negative 6, negative 63 is the sum of these terms. That's arithmetic series, geometric series coming up next.